In this lesson, we're going to look at sets and set notations. We're going to look at some of the number sets that we've already talked about. We're going to look at how to represent sets of numbers, learn some new terminology and some symbols. When we talk about a set of numbers, we're talking about a collection of objects or numbers, in this case, whose contents can be clearly determined, and the objects are called the elements of the set. So some symbols. When you see these curly, I tend to call them curly brackets. The correct term for them is braces. The correct term for the round brackets is parentheses, and the square ones are actually called brackets. When we're talking about sets of numbers, we always use braces. And so it's really good to get used to practicing writing them. They're kind of hard to draw sometimes. So we might have a set of numbers like 6, 7, 8, 9, etc. Those three dots are called ellipses and mean that the pattern continues on. Okay? Another way that we might represent a set of numbers is we could use words and other symbols. We could say it's the set of, we always say the set of when we see that opening bracket, brace, sorry, x, such that x is a counting number greater than or equal to 6. Now, lots of words in the way that one's done, and we're going to look at more ways to symbolize that. One other symbol that we need to know is the symbol that's used for the empty or null set. So that means a set that doesn't have any elements. It does not mean the same thing as 0. But the symbol that's for it looks like a 0 with a line through it, and that represents the empty or null set. So let's do a quick review of the number sets. Okay, and we're putting symbols with them now. So capital N represents the natural numbers, and remember those are our counting numbers. So 1, 2, 3, 4, etc. W represents the whole numbers, and remember the whole numbers are the same as the natural numbers but include a 0. We use Z to represent integers, and recall that the integers are the whole numbers plus the negative natural numbers. So we have ellipses at both sides to show that the numbers go on in both directions. Okay, and then we come to the rational numbers using the letter Q to represent them. And that is the set of all numbers A over B such that A and B are integers and remember B does not equal 0 because we can't divide by 0. Okay, irrational numbers, and we had an introduction to them earlier, and they're represented by the letter I, so it's important not to confuse the Z for integers with the I for irrational numbers. And the definition of irrational numbers is really the opposite of rational numbers. It's the set of all numbers whose decimal representations are neither terminating nor repeating. Okay, so they can't be expressed as a quotient of integers. And then finally, real numbers, which is the one new piece today, represented by the letter R. Real numbers are the set of numbers that are either rational or irrational. So it combines both of these two sets, okay? So it's a set of numbers that are either rational or irrational. So that's the set of numbers. We will actually later in the course be looking at numbers that are non-real as well, and that's a whole other interesting ball game, and we'll get to those later on in the course. One other symbol that we are going to need when we're representing sets is this symbol, and it looks sort of like an E, but don't make it into a square capital E. It's always rounded, but it's like an E, and it designates the symbol means it is an element of, okay? And you'll see in a second how we use that symbol. So we're going to look at a couple of different methods of representing sets of numbers by looking at 4 examples. So we're going to show 2 ways to write the integers from -5 to 10. So one step would be just to say, well, it's a set of numbers from -5 to 10, so it'll be -5, -4, etc. And we can close that set. So we can, for some sets of numbers, we can actually list all of the elements of the set. And so we just put the curly braces around it to designate that it's a set. This is called the roster method, when you can just list the elements. But sometimes there are too many elements to list, or it's a set of numbers that's impossible to list all the possible values. And so then we use what's called a set builder notation. And because we're talking about integers, those are the z's, right? So we could also write the same set of numbers as the set of all x that are elements of integers, such that -5 is less than or equal to x, which is less than or equal to 10. Okay, this is called set builder notation. Okay, so let's look at the elements of that one at a time again. So the curly brackets means we say the set of. And we're just going to use x to represent all of the elements of the set. And we're saying that all of the x's are integers. This vertical line reads as such that. And what we do here is if there's a low end and a high end, we put x in the middle and use either less than symbols or less than or equal to symbols. And we start low, put x in the middle, and end high, and we close the set off. Okay? And you'll have lots of practice with doing that. One other way that would be perfectly correct, that we could also use set builder notation, we could say that x is an element of the set of integers such that, and we could say -6 is less than x, and x is less than 11. So notice here we just changed the less than symbols to less than, and instead of including the borders, we just went one lower and one higher. So this one is correct as well. This one may be less confusing because it actually has the numbers that are in the set written in the description, but both are correct. Okay, question 2 here looks at a set of numbers, and I'll just write them out for you first. So it's the set of negative 12, negative 0.57 repeating. That little line means that it's 0.575757. It repeats. Um, it, it's a non-terminating decimal. 0, the square root of 3, the square root of 49, and the square root of 51. So for this set, we're going to list the natural numbers, the integers, the rational numbers, the irrational numbers, and the real numbers. So for the natural numbers, look at that set. Which of the elements are natural numbers? Remember, the natural numbers are the counting numbers. And although the square root of 49 does not look like it's natural because of the radical symbol, the square root of 49 is actually equal to 7, so it is a natural number. For the integers, and that's the letter Z, which of these numbers would be integers? Well, integers, remember, include all the natural numbers and 0 and their opposites. So that will include the square root of 49, which is a natural number. It will include the 0, and it will include the negative 12. So I'm just going to put them low to high. So negative 12, 0, and the square root of 49. Those are the integers. The rational numbers on the list, remember, rational numbers are any number that can be expressed as in fraction form or as a ratio of two integers. So rational numbers actually would include all of the natural numbers, the whole numbers, and the integers, because you could just put a 1 underneath them. They'll look like fractions, therefore they're integers. And then we can also include that repeating decimal, because every repeating decimal can be expressed as an integer. Notice that the definition for irrational numbers is that the decimal is non-terminating, so it's non-ending, and it's non-repeating. But since this one is repeating, it's rational. So the rational numbers will be negative 12, negative 0.57 repeating, 0, not the square root of 3. That one's irrational. Root 49 and root 51 will also be irrational. If you see any radical that doesn't simplify further, you can include that as an irrational number. So our irrational numbers here will be all of the ones that are not rational. Okay, so once we hit irrational, we're not including any of the ones that were in any of the other sets. So it'll be the square root of 3 and the square root of 51. And then the real ones will be all of them. All of them are real because real numbers consist of all of the rational numbers and the irrational numbers. So we'll just say all of them. And that's our introduction to sets of numbers.